All right, welcome back, or just welcome if you're not back from anything. Uh, Here we go. We're going to do some more tangent and normal lines. And hello, everybody. We're going to get things started. The first set of questions that we did in the previous video, it was more like given an equation and given a point, find the equation of the tangent line to the curve at that point. In this new section, what we're going to do is we're going to take a look at some other things. So before we even address this particular question that we have here, you're going to see a lot of this come up over the next few days. This whole business of horizontal tangents. So first of all, think about what each word means. Horizontal is a horizontal line. Horizontal lines have slope of 0. Okay, if you were skiing and your ski slope was horizontal, you'd say, where's the slope? There's 0 slope here. So that's what's happening. Okay, you have a horizontal tangent. Well, if something's a tangent, and it's going to look something like this, one thing you know, or now you know, is that when you have a max or min point on your graph, you get a lot of those with polynomial functions. The tangent line at a max or min point is a horizontal line. So the slope of a tangent line at a max or min is equal to 0. We're going to keep that in mind when addressing this particular question and probably a bunch of questions in the near future. Let's take a look at this one. Find the x value. So we're not looking for the x and y coordinate point, but some point or points on that graph. We have horizontal tangents. We have max and mins. Okay, so let's get the derivative. And once again, okay, the derivative of a function would be basically what you would want to do for every question. Okay, and in fact, if you get stuck on any question, you're going to get the derivative, and that could be 1 point out of 5 for any random question that you're given an equation for. Almost everything in this course would require you to at least get a derivative of a function. So using the power rule, I got the derivative of this right here. But unlike the previous questions where I was given a coordinate point and I want to put an x value into the derivative, this time out, okay, we are told to find the x value. And instead of calculating the slope, we're told that the slope is 0. Well, we're told that in not so many words, okay? We say that the tangent line is horizontal, but a horizontal line has a slope of 0. And now we need to solve for x. Well, the actual math that you do here is just some factoring, okay? You could use quadratic formula, but in this particular case, okay, you could factor this down, and then what you'll find is you get x equals 6, x is equal to -2. Some questions might require you to get the y coordinates for each of those points, but in this particular question, it just asks for x values, and so we are finished. Now, this is not required, but why don't we jump into Desmos and just take a look, okay? If we go into Desmos, this is the graph that you were given for question 1, example 1, and then we were told that there are horizontal asymptotes at x is equal to -2, which you can see right here, okay, that's a maximum point, so the tangent line would be flat. And then again here, at x is equal to 6. You can see that's a minimum, and the tangent line there would be horizontal as well. So really, with that particular question, okay, you are asked to find the x values where the graph has horizontal tangents. Another way you could be asked that question is just to find the min and max values. All right, so we have example 1 taken care of. Let's take a look at a second example. And this time out, we're going to show that this particular curve has no tangent lines with a slope of 5. Whenever you see the word tangent, we know we're getting the derivative. So what I'm going to do right here is I'm going to get the derivative. And once again, I'm not given a coordinate point, so I'm not going to plug anything in for x. We're told what the value of the derivative is. And remember that the derivative is the slope of the tangent. Don't have to write that in, okay, but it's a good reminder. And we want to make that equal to 5. Okay, if we're given a coordinate point or an x value, we plug that in for x. Here we're told that that whole entire equation is the slope of the tangent and must equal 5. So now we're going to solve for x. You can see here that there is going to be a problem with that. Okay, we get x squared is equal to -1/2, and that's impossible to solve. Okay, but you can't, when you get the square root, you can't get the square root of a negative number. So this would be no solution. And there's not supposed to be a solution. Okay, you're supposed to show that this curve does not have any points on the curve where the tangent lines have a slope of 5, and we just proved that there are no x values for that. And then finally, we have a third example here. Find the point on the curve. So because they say point, unlike question example 1, we're actually looking for an x and y coordinate here. And we want to find where they are tangent to this line right here. Well, this line has a slope of 2. Okay, it's parallel, sorry. Okay, parallel lines have the same slope, all right? So whatever the tangent line is going to be parallel to that line. So let's get the derivative, and before I get the derivative, I'm going to rewrite the equation without radicals, and then I'm going to get the derivative, which looks like this, and I'm told that it has to have a slope of 2. But I'm told that it has a slope of 2 and not so many words. I'm told that it's parallel to this random other line. This line of y is equal to 2x minus 4 isn't a tangent, but that line will be parallel to the tangent that we find. So now we just have to solve for x here. So how are we going to do that? Well, what we can do is we can bring the x's to one side. So this is really 1 over 2 root x if I bring it down on bottom. And then bring the 1 over. So we get 1 over 2 root x is equal to 1. Or 1 over 1. We can cross multiply. So we get root x is equal to 1 over 2. To get x by itself, we can square both sides. And if we square both sides, you get 1 over 4. That's just squaring the square root of x. Squaring the fraction. The square of 1 is 1. The square of 2 is 2. And there we go. Okay. So we know that we have an x coordinate of 1 over 4. We're also looking for a y coordinate to go along with that. So what you need to do is you need to make sure you put that value back into the original function. So what I'm going to do now is I'm going to go back and I'm going to plug that in. So I have y is equal to 1 over 4 plus the square root of 1 over 4, which is 1 over 4 plus square root of 1 is 1, square root of 4 is 2. And then you can get common denominators and add those together. That's 1 over 4 plus 2 over 4, which is 3 over 4. And then we can get our point right here of 3 over 4. That is the coordinate point. Let's go take a look at some things here. Okay, if we sketch this graph on Desmos, so let's get rid of this old one and throw in these new ones. Okay, so first of all, one thing you'll notice is that this curve in blue is the curve of your graph. Green is a linear equation, but it's not the tangent line. Okay, but what we are told is that the tangent line at 1 over 4, which is 0.25, if you get the tangent line at that point, it would be parallel. I don't have the tangent line, so I'm not quite sure what it is, all right? But if I drew, but it would be parallel to that line. All right,